Morning, everyone. First of all, I'd like to begin today by acknowledging the Lunguru Kaba and Bindal peoples as traditional custodians of the land which we gather today, and pay my respect to their elders, past, present, and the future. I'd like also to introduce our candidate for today, Juan Silva. He's originally from Chile. He got a bachelor's degree in sociology from Universidad Católica de Chile, and then did his master's in environmental science and management at University of California, Santa Barbara. And then he spent 2 years as a fellow, Coastal Solutions Fellow at Cornell University. And obviously, the next step will be to join us here at KCU as a PhD student. Without further ado, Juan, the floor.
Thank you very much, Ren. Good morning. Welcome, everyone. Thank you very much for being here. My name is Juan Silva. Now I'm going to be presenting my confirmation of candidature seminar on addressing governance challenges for sustainable coastal wetland management. So I want to start by defining wetlands according to the Ramsar Convention, which is the highest intergovernmental authority on wetlands, as areas with water that is static or flowing, fresh, brackish or salt, including marine areas not exceeding 6 meters of depth at low tide. Ramsar Convention, however, does not provide a specific definition for coastal wetlands, but it does provide a typology that includes river deltas, salt marshes, tidal flats, mangroves, estuaries, and coastal lagoons, as well as marine wetlands such as coral reefs and seagrass meadows. My research is going to be focused on this first group of coastal wetlands lying at the intersection of freshwater, marine, and terrestrial ecosystems. So coastal wetlands play a vital role in fighting climate change by sequestering carbon, buffering extreme weather events, providing key habitats for biodiversity and fisheries, and help regulating water quality and coastal erosion, among others. They're also essential for livelihoods as they provide food, raw materials, and multiple key recreational and cultural values. In economic terms, it has been estimated that estuaries and tidal wetlands like mangroves, salt marshes, and tidal flats contribute around 8.2 trillion per year, which is around 17% of total wetlands ecosystem services value. A study by Murray et al. Estimated that tidal wetlands cover around 355,000 square kilometers, which is 3% of the total wetland area. And the same study estimates both losses and gains in the past 2 decades of tidal wetlands, resulting in a net loss of 4,000 square kilometers. However, it's very important to mention that these figures only account for habitat loss and don't account for ecosystem degradation in other types of indicators, such as pollution. In fact, pollution from different sources is a major driver of degradation, along with land conversion for productive uses, aquaculture, damming, dredging, and of course, climate change, altering precipitation and temperatures, increasing extreme weather events, and rising sea levels, which poses particular dangers to the estimated 1 billion people that are going to be living within coastal areas in this century. So it's the location of coastal wetlands at the convergence of marine, freshwater, and terrestrial realms that makes these threats not only very abundant, but also very complex, operating at multiple scales and in different directions across realms. A fundamental implication of this is that the successful management of coastal wetlands require governance systems that can match the complexity of these ecosystems and the scale and directionality of the threats affecting them. By environmental governance, I understand the broader processes and institutions for making decisions that affect the environment, and environmental management as the outcomes of such decisions as actual actions and operations. So when scales of governance do not fit the environmental relevant scales of the problem being governed, we run into the pervasive problem of mismatch, misalignment, or misfit, which according to the literature results in inefficiencies, externalities, and allows environmental degradation to persist and in many cases to intensify. For example, a municipality with a small jurisdiction that is unable to manage upstream pollution. So based on the literature, this research is greatly based on the assumption that the problem of mismatch is one of the most, if not the most, important reasons for historical failures in management of coastal wetlands, thus its persistent degradation and loss. So just to operationalize a little bit more the concept of governance, I want to show this figure to describe briefly the three pure or silo types of governance in the literature, which is either state-run, market-based, or community-led. Those concepts are what Elinor Ostrom describes as panaceas, which she defines as a blueprint for a single type of governance that is applied to all environmental problems. Ostrom, along with many other scholars in this field, call to go beyond these panaceas by admitting and recognizing that one size doesn't fit all. And this means to recognize the increasingly hybrid networks of governance that are adapting to diverse, complex, and dynamic ecosystem and challenges. So with this in mind, I want to state my main research questions, as what are the social, ecological, and institutional factors contributing to misalignment in coastal wetlands governance. To respond to this question, my main research objective is to advance our understanding on the design of governance architectures that can enhance social ecological alignment in coastal wetlands governance, particularly in response to those cumulative multi-scale threats. So to achieve this, my research is structured in 2 chapters based on secondary sources and 2 chapters based on primary data collection in Chile. My first chapter, I will quantify and classify threats to coastal wetlands based on scale and directionality through a systematic literature review. Using the findings from chapter 1, in chapter 2, I will conduct a comparative case study to examine key drivers of misalignment in coastal wetlands governance and threats affecting them. Chapter 3, I will apply a social ecological network analysis to identify scale mismatches in coastal wetlands governance in Chile by analyzing critical nodes, ties, and patterns to inform opportunities for intervention. And in chapter 4, I will apply a choice experiment survey to assess what are the optimal design attributes of potential payment for ecosystem services that can help as complementary solutions for coastal wetland management in Chile. So as I said, the research setting is in Chile, specifically for estuarine coastal wetlands and its interconnected ecosystems, such as watersheds and adjacent coastal marine areas that differ in characteristics, socioeconomic context, and of course, very different threats. Those are from north to south, the Coquimbo, Metropolitan, Maule, and Los Rios region. Excuse me. Chile presents a really interesting opportunity for this research because it's a country that highly depends on coastal ecosystems with more than 4,000 kilometers of continental coastline and over 700 coastal wetlands, of which, according to a recent study, 42% are impacted by climate change and 53% face threats from land use change. Additionally, there's an important lack of research in coastal wetlands governance, and there's new legislation promoting novel tools for integrated watershed management, biodiversity protection, and climate change mitigation, among others. So now let's take a closer look to chapter 1, in which I will quantify and classify threats based on scale and directionality. So the main drivers of coastal degradation and loss have been widely covered in the literature, and usually with a common emphasis on the importance of the spatial scale of those threats. However, relatively few studies have focused on the importance of the directionality of those threats. This figure shows the sources and directions of different threats from operating across land and sea ecosystems. And in this example, non-point source effluents from the upper river basin affecting marine ecosystems, and showing the absence of feedback between upstream and downstream ecosystems and users. So I argue that a combined understanding of both scale and directionality of the threats could be instrumental to inform the design of proper governance schemes in coastal wetlands by focusing not only on its effectiveness, but also on equity issues. So this said, I wanna put my first research gap as a lack of emphasis in the systematic understanding of threats based on both scale and directionality, and linked to this, a lack of research integrating this information in order to inform the design of governance schemes that can help address the problem of mismatch that we already mentioned. So for this, I want to answer the following questions. What's the scale and directionality of threats, and what's their frequency and distribution across different types of coastal wetlands? The expected output of this chapter would be a typology that can lay the foundations for the design of governance, context-based governance solutions across different types of coastal wetlands. So after an initial search in Web of Science and Scopus databases following the PRISMA framework for systematic literature review, I'm now in the process of screening a selection of 1,279 articles. On each of these articles, I'm extracting a maximum of 3 threats that are classified according to scale and directionality, as we see in this figure as an example of the scales and directionalities I'm considering, and some examples of their combinations. So local scale, for example, means that the threat extends within the coastal wetland or immediately adjacent sites. Subnational means that the threat extends within a specific region of a country and usually matches the watershed scale. Regional is basically another word for transboundary, spanning different countries, and global is, well, self-explanatory. Regarding directionality, land to sea obviously means that the threat originates from inland sources affecting downstream ecosystems. Internal means that it has no directionality, usually matching the local scale. And sea to land means that the threat originates from marine or coastal marine environments towards land. So now I want to show some very preliminary analysis with so far 50 papers I've reviewed. This figure here shows the distribution of threats according to their scale and directionality. And we can see that the most frequent combination is land to sea threats occurring at the subnational level. As expected, most of local threats have no directionality, and sea to land threats originate mostly at a global scale. Now I want to take a closer look at the circled areas. The first one, the combination of land to sea at the subnational level, is mainly composed of effluents that are distributed in a balanced proportion between agricultural, forestry, urban, and industrial effluents. Secondly, the internal threats at the local scale are mainly composed by physical alterations to the coastal wetlands, like canalization, dredging, and expansion of urban areas, in some cases of aquaculture, mostly shrimp farms in mangrove forests. And the third category, it's composed mainly by sea level rise, which is classified as habitat shifting and alteration, according to Ramsar. And half of the other threats are mostly storms and flooding. So those are very preliminary results, but I expect that expanding the scope of articles will provide a more robust basis for further analysis of trends, and also to provide the typology I want to develop. So now let's go to chapter 2, in which I will examine key drivers of misalignment through a comparative case study analysis. I want to go back to this figure to highlight that abundant research has been done on this component of multi-partner governance to analyze and classify diverse combinations of governance systems, such as collaborative, multi-level, or polycentric governance. This is a very small selection of a much broader set of categories, which are really fundamental for a discussion on governance. However, my real interest is to understand what constitutes effective governance in the specific context of coastal wetlands. So this paper, for example, from 2018, highlights some common themes in the literature of governance in coastal wetlands, like adaptation and resilience, collaboration, social learning, polycentric and decentralized governance, participation and co-management. And a more recent paper matches some of these common themes in the literature, like politics, institutions, land tenure, economy, resources, policies, and behavior. So those findings and discussions have been really key contributions to my understanding on this subject, and has led me to an even more specific interest, which is that I'm looking to frame the effectiveness of governance as one that matches, again, the characteristics of what's trying to be governed, in this case, coastal wetlands and threats affecting them. So this brings us back to the problem of mismatch. Cumming et al. In 2006 provided an important basis to diagnose scale mismatches at different scales. For example, the spatial scale, with the example I already provided, the temporal scale, for example, large and slow bureaucracies that are unable to deal with rapid ecological changes from an invasive species, or functional scales like an institution aiming to protect a shorebird but failing to take into account key functional processes such as migration or trophic webs. So far, most of the research on scale mismatches have focused on theoretical descriptions and discussions, while the empirical diagnosis approach has used more quantitative approaches. And the few qualitative approaches to diagnose mismatches have focused mostly on single case studies, which brings me to my second research gaps. The first one being a lack of qualitative comparative studies to diagnose scale mismatches in governance, particularly in coastal wetlands. And also there hasn't been any diagnosis of this kind using the directionality and scale of threats as the point of reference, which is what I will do. So in chapter 2, I aim to answer the following guiding questions. What are some key factors that enhance or constrain the alignment of governance in coastal wetlands according to the threats affecting them? And what are the performance, interactions, and combinations of those different governance systems in managing those threats? The expected output here is a descriptive insights on the main drivers of mismatches between governance systems and threats in different types of coastal wetlands. So based on the findings from chapter 1 and complemented with other sources, I expect to select from 5 to 10 case studies that range in a variety of threats and governance systems that count with abundant available data and include both cases of success and failures to enable comparison. Data collection would include academic and gray literature, paying special attention to relevant governance components such as system size, actors involved, property regimes, regulations, and the broader socio-political context, among others. For this, I will guide myself with the institutional analysis and development framework by Ostrom in combination with other potentially relevant governance frameworks. And I will use qualitative coding techniques and RStudio for data visualization. For now, I want to go to chapter 3, in which, as I said, I will apply social ecological network analysis to identify scale mismatches in coastal wetlands in Chile. So just to set the stage, environmental governance can be also understood as networks of diverse actors interacting to manage natural resources and ecosystems. And oftentimes existing beyond formal institutions, research has shown that network configurations, certain patterns, can play really important roles in governance outcomes. For example, centralized networks allow bridging actors to facilitate coordination for rapid problem solving and crisis response, while more densely connected network fosters stronger ties and trust, thus promoting cooperation and collective decision-making. Additionally, a network approach can also help to map key players and underrepresented or even missing players in relevant networks and identify gaps that can be filled to improve management. However useful, traditional social network approaches do not account for ecological units that form interdependent relations with social units, which limits their ability to analyze social ecological interactions. To overcome this limitation, social ecological network analysis has emerged as a tool that examines the links between social and ecological units to uncover patterns, configuration, or what has been called as building blocks that improve social ecological fit, thus supporting better conservation outcomes. For instance, this building block, as shown in Barnes et al., is a closed triangle involving two social units at the top, for example, users or managers of an ecosystem, a resource, or even an environmental issue, the ecological unit at the down, the green unit. So this configuration exemplifies social ecological fit by promoting collaboration that is tied to the ecological context. So this approach has been applied to identify scale mismatches in different contexts. I will not get into details, but I just want to show some examples. This one is water and was applied in watershed restoration, estuary watershed restoration, in transboundary coral reef management, and also in collaborative wetland management between municipalities, among others. Despite its promise, this approach is still relatively new, which poses both theoretical and methodological gaps. Among those, I identify the following. There hasn't been enough application of this approach, focusing on coastal wetlands as the central ecosystem of interest. Secondly, the hypotheses about network configurations for optimal governance outcomes are still under debate. And thirdly, and very important, there hasn't been any applications of this approach in Chile, which offers really interesting opportunities. So for this chapter, I want to answer the following guiding questions. What key social and ecological units must be aligned, and in what ways to achieve optimal social ecological performance? And what are the mismatches of the jury, which is theoretical, meaning like networks present in regulatory instruments and policies, versus de facto social ecological networks, the ones that are actually operating. So the expected output here is an analysis and a graphic representation of social ecological mismatches, which could eventually inform intervention opportunities for enhanced management of those ecosystems. So again, the research setting are those 4 sites, which differ in socioeconomic and geographic context, but very importantly, very different threats. So I want to show a quick example. The northern region of Coquimbo, the mining operations shown as purple diamonds are way more pervasive and frequent than in Los Rios region at the south, in which forestry operations appear to have more presence and therefore be a more important threat. Same with the other 2 regions, but this is just for illustrative purposes. So for data collection, I will apply a survey to identify and measure ties, and I might include additional questions on decision-making, property regimes, agency power, conflict, perceptions of equity, and future scenario assessment, among others, that prove relevant upon a first exploratory fieldwork. And as I said, also regulation analysis of de jure networks. So to show what are the social and ecological units and patterns that are gonna be studied in this research, I wanna show this very simplified scenario in which social units will be actors that have an interest or stake in threats affecting the ecosystem. In this case, a municipality and a water users association. And ecological units would be identified as threats to the ecosystem, for example, land conversion and effluent discharge. So the green line in this case would mean that actors are collaborating between them. Sorry. The red line would mean that the ecological units, meaning the threats, are interdependent between them or reinforcing each other. And the black lines would mean that both actors in this case have roles in managing the threat of effluent discharge. So hypothetically, this would form this building block that we already saw, the closed triangle that would mean tight coordination or social ecological fit. And hypothetically, there would be a lower level of fit if there's no collaboration between the social units. And other structures like this would have, when both collaborating actors have roles in managing both threats, would have to be assessed against existing evidence and hypotheses. But one option that could make things more complex, but very interesting, would be to introduce institutions or venues of higher level of decision making. And then we could evaluate how patterns of venue to actor to issue relations play out in terms of management. So all those options are still open. Those are very simplified and hypothetical scenarios. The actual units, links, and patterns to analyze will be determined, as I said, in a first stage of exploratory fieldwork. So a common analysis to understand which configurations are most prevalent in networks are multi-level exponential random graph models using the MPNet software for multi-level networks. However, those are also yet to be determined upon we progress this project. So finally, excuse me. In chapter 4, as I said, I will conduct a choice experiment survey to assess what are the optimal design attributes for potential payments for ecosystem services programs to be applied in coastal wetlands in Chile. So I'm gonna go back to this figure one last time to emphasize the increasing interest in the use of market-based instruments in environmental management. Because when properly designed, those instruments can be helpful in complementing existing other governance systems by providing tangible incentives to stakeholders to engage in sustainable practices. Those market-based instruments comprise a wide range of mechanisms like certifications, carbon trading schemes, biodiversity offsets, among others. But in this research, I'm particularly interested in exploring, for now, payment for ecosystem services, which are flexible and voluntary agreements between parties to translate not market values of the environment into real financial incentives for local actors to provide services such as flood control, biodiversity, water quality, among others. So what's interesting is that coastal wetlands offer a clear potential for voluntary adoption of such instruments, given the evident connections between management of the upper watershed and the cumulative threats creating externalities downstream. In this sense, these instruments offer the potential to make scale connections in the governance networks, thus helping mitigate scale mismatches. So probably a lot of you know this, but I want to just briefly go into the logic of how these programs work. For example, landowners receive fewer benefits usually from forest conservation than transforming their land to pasture, but this can create huge costs for downstream users. So those service users can transform those costs into payments to the landowner in order for him to adopt this new practice of forest conservation. So this is a very, very simple example and it sounds great. However, in reality, there's still a lot of debate around the success of these instruments, mainly due to lack of empirical evidence supporting their success, many challenges in measuring their impacts, and poor institutional structures to support their operation. So based on research and the literature, it is safe to conclude that the effectiveness of such instruments crucially depend on their design. This said, I want to state the research gaps for this chapter, which is there is a lack of preliminary social science research to inform the design of instruments like this one. There hasn't been enough applications of these instruments to coastal wetlands, plenty of applications in watershed, but not enough in coastal wetlands as the central ecosystem of interest. And third, again, those instruments are in a very, very early stage of exploration in Chile, which offers really interesting opportunities for real policy making. So My guiding questions again, what are the most important attributes for the design of such instruments? And what other institutional conditions must be considered in the design? The expected output would be to develop some guidelines for the design of payment for ecosystem services programs that meet the unique needs of coastal wetlands in Chile, but also can serve as a reference for other locations as well. So for this chapter, as I said, I will be applying a choice experiment survey, which are instruments that make people choose among hypothetical programs that have different program attributes. And then we assess the relative values that people place on such attributes. So let's take a quick example of a potential hypothetical payment for ecosystem service program, which with 3 attributes. The first one, type of ecosystem service with 4 levels. The second one, payment mechanism with 2 levels. And the third one, mediator of the transaction with 2 levels. Then we can sort all possible combinations of the attributes of the levels, of such attributes in different programs, and then place them in service and make people choose among them. So with a big enough sample, then we can apply conditional logistic regression models to estimate the probability of an alternative being selected as an additive function of its attributes, and therefore understanding what attributes are most important. So the sampling and data collection of this chapter will be mostly concurrent with chapter 3, meaning that I expect that an important overlap of actors being interviewed. And both for chapter 3 and 4, qualitative data will complement findings by providing contextual insights. So now to start finishing, I want to talk about some overall expected outcomes of this research. First of all, based on the first 2 chapters, I would expect to provide some guidelines for the design of context-based governance architectures for different types of coastal wetlands suffering from different threats, and also a template for future research and comparative case studies. Secondly, the use of social network analysis in Chile can be useful not only as a novel tool for decision making, but also to set a baseline for long-term longitudinal analysis that can trace and evaluate the impact of different policies and interventions. Third, the guidelines for design of payment for ecosystem services, as I said before, have the potential for real applications in policymaking in Chile, and I expect to be useful for other locations as well. And lastly, this study could generate insightful contributions to the literature on environmental governance by exploring new approaches to hypotheses on social ecological fit and network configurations, among others. This is my work plan. We are now in the yellow stripe. The light blue squares are processes like fieldwork, data analysis, and also an internship that I will be starting March next year with the Nature Conservancy, mostly focusing on the context of chapter 4. The green squares are the submission of each of my chapters, and the red squares are the university milestones, like the mid-candidature seminar, which I expect to cover with a presentation in a conference yet to be determined. And I expect to finish all data analysis for all chapters by mid-2027 and be ready for my pre-completion seminar and thesis submission. This is an outline of my chapters with a publication plan. You can check on it later, more detail. Regarding ethics, I have already complied with all required courses, and the survey that will be applied will include both contents from chapter 3 and 4 and will be consented, anonymous, and very low risk. The submission of this instrument is expected to be applied in around March 2025. Regarding risk management, there is going to be extensive fieldwork and intensive stakeholder engagement for the application of surveys, and both of those risks will be managed through my previous professional experience on this type of research, my familiarity with the research context, and multiple supporting networks in those sites. So this I want to finish. thanks to my supervisor, Reniel Cabral, Nathan Waltham, Rodrigo Ayanadel, and Stefan Gelsich, to my colleagues from the Fisheries Reform Lab and to James Cook University. I also want to give special thanks to Michelle Barnes, Steve Gaines, Marcus Sheaves, Georgina Gurney, Amy Driadich, Nicolas Murray, and Manuela Diaz. Thank you very much.
Questions in the room or online? David.
Nice talk. I was just wondering, where does restoration fit into your analysis, considering there's so much restoration activities happening even in coastal wetlands? Have you considered the concepts of restoration and how that fits into some of the modeling and some of the understanding?
That's a really good question. I was actually reading one of Nathan's paper yesterday about restoration and thinking that I didn't mention that concept, and it's a really important one. I would say, in the first place, it's kind of implicitly stated in the efforts of management, of sustainable coastal wetlands management. So there is going to be some cases which, of course, restoration will be an urgent action, whereas in other places would be to maintain, the ecosystem or prevent it from changing, substantially to another equilibrium. But yeah, I think that's a really good point. I will make sure to include that more explicitly. But I think that the analysis in general of the first two chapters and so on will show this concept will come up for sure. And yeah, but that's a really good point. I'll have to think more about that.
Very, very nice question. Other questions?
Sorry, I want to add, I think in chapter 3, there's also going to be quite a good amount of that, given the potential role of payment for ecosystem services or potentially other market-based instruments to focus particularly on restoration efforts.
Yeah. We can discuss it also, like the chapter 4, where you design payment for some service, maybe like by restoring habitat, if it provides like services to other areas or other stakeholders, then that can be accounted for. I mean, yeah. But of course, it depends on the context whether that's being considered in the study area. Other questions?
Simon.
Yes, Simon.
Thanks. I was wondering if I would pop up on the screen there if I stuck my screen on. Anyway, a question and a comment. And my questions are kind of a small technical one. I'm interested in this concept of directionality, and because I just assumed most of it's land to sea, or land to wetland, and it seems like effluent and runoff is the kind of the biggest thing, plus climate change. But you had a category of sea to land directionality, which included overfishing. I'm sort of not sure how that works. How does overfishing impact on wetlands? Is that overfishing in the sea impacting on coastal wetlands or what?
Yeah, those are just kind of illustrative examples. I found just very few examples showing that overfishing in estuaries in general, which are obviously connected to the adjacent, coastal marine areas outside of the estuary. Therefore, it's kind of an internal threat, but also could be considered something originating in the ocean, from fishers that have their infrastructure and operations based on the coast, not necessarily in the wetland. So it could be an option, but yeah, that could be, of course, refined those categories.
I suppose if you had amphidromous fish and there was overfishing of the marine population, it could impact on the ecology of a wetland or a freshwater system. Okay, my comment is about payments for ecosystem services. That's actually the subject of quite a big literature in political ecology, very critical. and quite a bit of that is highly empirical as well. So I'm happy to send you some stuff about that. So it's not really a gap. As I think you said, it's most political ecologists are quite concerned about the idea, and they think it's pretty dodgy. But yeah, maybe we can discuss that. I'm not gonna say that it's it's never gonna work. And there may well be evidence for it working in some places. In Australia, there's a guy called Andrew McIntosh who's been very critical of the carbon trading system as it's been cooked up by the government here. So he basically calls it fraudulent. That's his word. And I'm sure you're familiar with some of those criticisms, but there's also a pretty strong theoretical criticism, or set of criticisms coming from the political ecology field. So yeah, and my other kind of just quick comment about networks is the state doesn't seem to be getting a lot of prominence in your analysis. It's kind of there by implication, but for me, systems thinking, and I've been thinking about systems and sort of intersecting with systems thinkers for a long time. I'm not a massive fan. It's sort of intrinsically depoliticizing, and the politics can often be extremely important. So the state, I think, maybe could use a little bit more spotlight in your proposal. It's it's kind of where the rubber hits the road for so many environmental issues. If you think about the Great Barrier Reef zoning achievement back in 2004, that was really mostly facilitated by a Liberal Party politician, the late Virginia Chadwick, who was able to persuade an extremely conservative prime minister that it was a good idea to zone up the GBR. So that's just pure politics. So I think maybe have a bit of a think about that, and I'll be quite happy to chat with you about it as well, as we go along. But yeah, any comments you have on that?
Oh yeah. Yeah, no, those are awesome comments, Simon. Thank you so much. Actually, I was expecting, based on our conversation yesterday and some other times with some fellows, about the controversial nature of those market-based mechanisms that, as you said, some scholars call even fraudulent. And what I was responding yesterday to my colleagues was that eventually one of the outcomes of this fourth chapter would be that payment for ecosystem services are not a good solution. It could be the case. So there could be other types of interventions based on findings from chapter 3, in which I will address the state part after this response. But I think it's very, very interesting what you suggest to include more of the political ecology discussion about those types of things, even enable like a critique of the concept of governance itself. So what does it mean to have a good governance or good governance outcomes, as I think one of your papers as well discussed. And that's one of the reasons I also was planning to include questions in the survey regarding dynamics of power, agency, equity, and stuff like this, because it's going to be key to inform the design of potential interventions. And the other thing was, the state part. It's really important in Chile, especially for chapter 4 as well, because in Chile we have, I don't know if you're aware of this, but one of the most privatized markets of water rights in the world. So that's a really important thing to keep in mind. I didn't want to mention it here because it could have transformed the whole presentation on that. But it's a huge discussion. It was like a policy that was enacted during Pinochet's dictatorship, and it hasn't been changed at all since then. And it's very outdated, and it's basically like monopolies of water rights. So this could give place to very perverse incentives if you place instruments like payment for ecosystem services without the proper analysis. It could make the rich even more rich, and so those types of things are going to be fully considered. I would really appreciate for you to send me some more literature, and we can chat later on that. I was actually very excited to have you here because of these types of questions. So thanks so much. I hope that I responded to some of the comments.
Right, thank you. That's wonderful. That's great. I did not know about that highly privatized water system in Chile. That's it's interesting how that contrasts with the Caleta system on the coast.
What?
The Loco fishery, which is quite different from that, isn't it?
Oh, right, yeah.
Yeah.
Yeah, it is. It is a very different system. When it changes to the coastal marine areas, we have this like turf system that is assigned to each. But yeah, that has been shown kind of as a success of like community-based or like polycentric governance in a way. However, the water rights system is pretty much on the right down corner of the figure by Lemos I showed all the time, which is like purely market. Yeah. So there has been some attempts to change that, but without success. But yeah, it's going to be a very important element to consider. I agree. So thanks for the comment.
Questions on the room?
David? Just for chapter 2, I noticed the case studies you're going to do, there's none from Australia. Why is that? Is there not any data, or is it just
case studies? You mean chapter
2? You're
going to do yeah, I mean, I haven't yet selected those case studies. There's eventually going to be one from Australia, or maybe more than one, because one of the criteria you saw there is that it comes with available data. And one of the really incredible things about Australia is the massive amount of data there is on ecological indicators, governance systems, etc. So there's very likely going to be an example. So far in the papers I've been reviewing of this massive selection I have, a lot of them are from Australia. So it's very likely that some will include, but again, I have not yet reached the stage of the selection. I will finish chapter 1, and by the end of it, I think I will have more data to be able to select those. Yeah, that's a good point.
Maybe the confusion was like the figure you showed, that's from a paper.
Oh,
paper.
Yeah. I was putting that as a complementary, potential source to take case studies. Another example I had was the Ramsar list of protected wetlands, which is interesting because they're already protected, and they do have a lot of information on what's affected and stuff like that. But yeah, I'll put that in mind for sure.
Other questions online in the room?
Sorry, can I ask a question? I don't know if you can hear me.
Of course, Rodrigo, go ahead.
Rodrigo Yanel here. So first, just wanted to say congratulations, Juan. This was a very interesting presentation. I think you've made a lot of progress in your PhD, so that's great. My question was if you could extend a little bit on your experience working in some of these contexts, especially following up on Simon's question on the role of the state, because there's some really interesting actions that are being taken at the local level, at the level of municipalities, for instance, in Chile. So some of the threats and some of the direction of those threats could be not so, but at least managed at the level of at a smaller scale, which could be the municipality, for instance. So can you explain a little bit more on how it works in Chile and your experience working in these systems?
Thanks. Yeah, no, that's a great question, and it allows me to explain a little bit more of the context of why I chose to perform this research in the first place. So what Ren mentioned at the beginning, my presentation was that I was like for 2 years involved in a program to protect a coastal wetland in one of the places I have as a case study, which is the Mataquito coastal wetland. It's a rather small estuary in the central coast of Chile, and as Rodrigo said, there is like this key unit that that's why I put it there instead of the state, for example, which is also a key player. But municipalities in Chile have really a good deal of power over their jurisdictions. Even though they're small, they do have really powerful local policy-making tools, such as one that is called ordinance. I don't know if it's Australia, there's something like that. But actually, in those 2 years, we managed to approve an ordinance that protected all the coastal wetlands of the municipality. So at least for the, let's say, local or maybe sub-national level, maybe at the sub-basin scale, coastal wetlands are effectively protected, and the municipality has the capacity to enforce different threats, including like effluents, discharge, and stuff like this. So even though there's like an overlap of legal tools and policies and regulatory instruments, which is a mess, obviously, I assume not only in Chile but other places, because of the very nature of coastal wetlands. But yeah, I think municipalities play a key role, and my experience working with them revealed that in a really surprising way. And the alliances between municipalities as well could have the potential to scale up in a really interesting way. And also regarding the state, and this I'll pick up also Simon's question, we managed to establish a committee between different actors at different levels, so like the fishers, the municipality, and also representatives from the state level. And that was a very kind of very basic example of what we call polycentric, like or multi-level, better said. And yeah, the state, of course, has a lot of stake in decision making, but I think that connection from the bottom up made policies and like top down are having a really interesting conversation, and it has like a lot of potential to address those scale mismatches. So I don't know, Rodrigo, if I answered your question, but yeah, I think in the network analysis, obviously state agencies will be another actor to consider. I didn't want to expand on that because it would have taken longer, but of course it's a very important part of the actors who want to integrate as well. So I don't know, Rodrigo, if I answered your question.
Yes, very clear. Thank you.
Thanks.
All right. Thanks everyone. Thanks